All right, here we have an exam style question on a strong acid, strong base titration. So the key to these is recognizing that they're fairly simple. It's a neutralization reaction between our H plus generated by our strong acid and our OH minus generated from our strong base. So what happens here is HNO3 is going to dissociate into H plus and NO3 minus. Okay, and then our sodium hydroxide dissociates into Na plus and OH minus. Remember, these two are both spectator ions. They don't get involved in any way. So we're really interested in just what H plus and OH minus do together. They just make water. Okay, so that's why these strong acid, strong base titrations are so much easier, because we're not generating some weak base or weak acid as we do the titration. We're just making water. In this case, we're looking at when we hit the equivalence point, and we're told how much of our NaOH we needed to add to get to that equivalence point. So we know the moles, or we can calculate the moles. We know the moles of OH minus added. And at the equivalence point, the definition of the equivalence point is that the moles of OH minus, and I should do moles rather than concentration brackets, which I just apparently really, really want to do, equals H plus. So if we can calculate this, then we can calculate the concentration that we had of H plus. All right, and so again, we're watching this. Somebody, as they were doing this, was monitoring the pH. They were waiting for it to hit 7, or they had an indicator that changed color around pH 7. Something, it's like message to the chemist in the lab that they had just hit the equivalence point. We don't get that information here. We're just told that they got to that EP, okay, and that they needed this much OH minus. So let's calculate moles of OH minus. So that would be 0.0225 liters times 9.5 molar. Zero 0.21375 moles. Okay, and again, at the equivalence point, that must be how much H plus was in our original vessel of that nitric acid, of that HNO3. So this must equal my H plus, again, not concentration yet, H plus moles and HNO3 moles. All right, so our last step is just to take those moles and divide it by the original volume of our HNO3. So we're not going to include the 22.5 mils that were added in. We'd like to know the original concentration of the HNO3 solution before we have added in our titrant. So we'll do 0.21375 moles of H plus divided by 0.435 liters. And again, because this is a strong acid, H plus is just a proxy. It's the same thing, going to be the same concentration as our HNO3. So 0.21375 divided by 0.435. This was a 0.49 molar solution, and it asks for 2 decimal places there. And of course, we don't include our units in these questions, but there you go.